Okay, now our third lot of identities are the complementary angle identities, and there's three of these ones as well. Okay, so what I'm going to do first is I'm going to start off by actually explaining the meaning behind some of the trigonometric ratios we have. Okay, so let's start off with sine and cosine. So sine and cosine. So sine and cosine are basically complements of each other. So remembering complement angles are two angles that add up to 90 degrees. So sine and cosine, or a way to remember it is co for complement of sine. Okay, so sine and cosine, if you were to add together, you know, so say sine of theta should be equal to 90 degrees, okay? So what this is basically saying is, if I had sine of 30 degrees, then that should be the complement, or the cosine complement of this will be equal to 60 degrees. And we know that because sine of 30 degrees, if we use our exact ratios, is equal to a half. And cosine of 30 degrees, of 60 degrees is also equal to half. So this statement here is true. So our complement angles are the same, or not are the same, but sine and cosine are the same when they are the complement of each other. So when both of the values add up to 90 degrees. So we can write a rule for this one, which is, so the rules, or the identities are for any angle theta, like we've been writing before. So the cosine, okay, of an angle, well, 90 degrees minus the angle, is just equal to the sine of that angle, okay? So like I said up here, so if we had, you know, cos of 90 degrees minus 5 degrees, well, that's equal to sine of that 5 degrees. So all this is saying is sine of 5 degrees and cosine is 90 minus 5 degrees will give you the same value, okay? So that's a really important tool, again, to use because it means we can interchangeably change sine and cosine based on the value that we've been given. So if we've been given a sine of 30 degrees, well, we can change that to cosine of 60 degrees in case we have a bunch of cosines. Now, the second identity that we have is the one for cot. Now, this one up here, cot, is cotangent. Okay? So the complement of tangent, okay? Or cot and tan. So cot and tan are related. So cotangent and tangent. So the cotangent, when 90 degrees minus that angle, is just equal to tan of that angle, okay? So if you have tan of 15 degrees, then your cotangent, or cot, that will give you the same value as tan of 15 degrees is cot of 75 degrees, okay? And the third one that we've got is the cosecant, okay? Now you might be saying, oh, what the hell is cosecant? Well, that goes with secant, which is the complement of secant. And again, you might be saying, what on earth is that? You know cosecant best as cosec. Cosec goes with sec. Okay? So, going back down to this one, and I'm going to talk about this one again in a little bit more detail than I have with the other ones. Okay, so cosec of 90 degrees minus theta is equal to sec of 90 degrees minus theta. Okay, so what does this one actually mean? Well, we know that cosec is 1 over sine, okay, because it's the reciprocal function. And we know that sec is 1 over cos of theta, or sec theta is equal to that. So what this rule is basically saying is if you have 1 over sine of 90 degrees minus theta, well, that's the complement of 1 over cos of theta, okay? So, in other words, if I had 1 over sine of 30 degrees, well, that's the same as the reciprocal of cos of 60 degrees, okay? So, That one is, I think, is really cool out of the three because it's basically saying, well, you know, cos and sine, well, the exact same thing happens with their reciprocals. And it makes sense too. Like, if you're dividing a number that's the same as another number, you know, you're dividing one by the same number. If I'm dividing 1 by 2 and 1 by 2, I still get a half each way. Like, it's going to give me the same number either way. And that's just a really cool one because I think you don't actually have to remember the fact that cosec and sec are complements of each other. Like, you know, besides the fact that their names, cosecant and secant, literally say that to you. But you can just, all you have to do is remember that sine and cosine are complements of each other. And then you can get cosec and sec by just literally taking the reciprocals of them. Anyway, this is our complement angled identities. These are the three identities that we're concerned about. Okay, so those are the three that we're worried about. And with that being said, let's have a look at some proofs in the next video.